So we are doing R4 part C. Oops, I gotta change this. Always forget something. Let's do that. All right. Okay, here we go. This is called division of polynomials. Remember the last thing we did on Friday? We did that division problem. It was like a regular division problem. I don't think I recorded it. But let's do it quickly. I'm not going to take as much time as I did on Friday, but let's just do a quick little review. So if I asked you to divide 842 by what, 15? Okay. If I asked you to do that, divide 842 by 15, here's how you would do this. And we're going to use this as our model problem to do what we're going to do with polynomials. This isn't polynomials, but we're going to use this as a guide, all right, to do the other division. So we're going to make this big old long division symbol like this, put the 15 out here, put the 842 in here. All right, and then here's what we do. Now, try to follow along. You might have already written this down, so you may not even have to write this down right now. It might already be in your notes. So we look at this thing right here, and we say, this thing on the outside of the box, we say, how many times does 15 divide evenly into 84? So we're kind of looking like 84 divided by 15. It doesn't come out even, but how many times does 15 divide into 84? Well, it goes in 5 times, because 15 times 5 is what? You guys did this yesterday, 75, right? Now, once we do that, and I'm doing this for a reason, because when we do these polynomials, you're really going to have to see this. Will, you getting all this? Okay, but you can still keep your head up and not down like that. Yeah, that would be helpful. So 15 times 5 is 75. Now, what do we do with that 75? We do what to it? We subtract. That's very, very important, okay? That may seem like, just an incidental step here, but it's super important what we're going to do on the next one. So we go minus 75. All right, and so we go 84 minus 75, which is 9. And then what do we do with that next number? We bring it down, okay? You don't have to put the arrow there, but, when they teach this in whatever elementary school, I guess, where they first do long division, they usually put an arrow here. We bring that thing down. And now we just repeat the same routine, except instead of 84, we're looking at 92. So we're looking at 15. How many times does 15 divide evenly into 92? Well, it goes 6 times. Again, it doesn't go evenly, but it goes 6 times. It doesn't go... That's the most number of times it divides into it, okay? So 15 times 6 is 90, and then we subtract a 90. All right, and now we do the subtraction. 92 minus 90 is 2. Do we have any other numbers to drop down? No, we don't have anything else to drop down. So what do we call this? This is our what? Our remainder. But remember what I said? We're not going to write R for remainder. We're going to write it as a fraction. Okay, so we just take the remainder, which is 2, and we put it over whatever we're dividing by. You with me on that? So it's very easy. Okay, a lot of you guys thought, oh man, fractions, I hate that. I always did the R. Why can't we just do the R? This is just as easy. All right, it's 2 over 15, and that would be your answer. Okay, we're not going to write remainders. That was when we were little kids. We put an R there because 15 times 6 is 90. All right, I just had to figure out. So what I would do, I would use calculator. All right, watch this. Have I shown you this calculator? Okay, so what I would do is, how do I clear that? Oh, for some reason when I tap with the pen, it doesn't work, but I got to use the mouse pad. If you wanted to, you could go 92 divided by 15. And to tell you the truth, the math on what we're going to do today with these polynomials is actually easier than the math here. You're not going to have to worry about this kind of thing. But if I hit enter, it goes 6 times. There's your 6, okay? So let me get rid of this calculator. All right, so that's how I know it goes 6 times. But it's 6 and a little bit, doesn't go even. So 6 times 15 is 90, subtract, and there you go. All right, now let's do an example I wish they would have given us a little easier one. I'm just going to make one up. That's scary. I think I can do it because if it's going to have a remainder, it doesn't have to come out even, so it doesn't really matter. So let me just make one up, all right? What's that? Yeah, but it wasn't a division, though. It wasn't like that we're doing right now. I'm just going to do this. Watch. Divide, I don't know, 5x cubed minus 3x squared plus 2x plus 1. I'm going to divide that by x minus 3. All right? I'm just making it up. Let's see if hopefully it works out. I don't know. Yeah, I'm making an easier one. I'm doing an easier one because I think it's not hard, but it's like half a step harder than this one, okay? Yeah, this is an easy one, okay? I told you at first it's going to look crazy, but after you do a few of these, it's not going to be as bad as what it looks. Oops, let me make this a little straighter. There we go. All right, we're dividing all this mess by x minus 3. So the x minus 3 goes on the outside, just like the 15 went on the outside of the other one, right? You got the other one in front of you, right? So we're going to use this as our guide, all right? It says divide 842 by 15. That means the 15 goes on the outside, the 842 goes inside. Well, this says divide all this mess by x minus 3. The x minus 3 goes on the outside. All this mess right here goes inside. So I'm going to go 5x cubed minus 3x squared plus 2x plus 1. Now, all the math that we're going to do in here, I promise you, all the math that we're going to do, you've already done before. We've already done some of this, okay? We know how to distribute, right? Remember distribute, FOIL, and all that kind of stuff? We're not necessarily going to do FOIL, but we're going to distribute stuff. We know how to divide, just monomials. Anyway, you'll see. It's something that you could do. What did we ask ourselves on this problem right here? We said, how many times does 15 divide into 84? How many times does it go into 84? So what did we basically do? We just went 84 divided by 15, didn't we? Which is going to be like 5 point something, all right? But this is kind of the same thing, except it's actually, I think, I don't know, maybe it's just me, but I think it's a little easier because I think the math, the arithmetic, let's say it that way, I think the arithmetic, is a little easier on this. What we're going to do is this. We're not going to look at the whole x minus 3 for right now. Let's just look at the x, and let's look at our first term right there. I want to find out how many times does x divide into 5x cubed. Do you remember the thing we did with the calculator? What did I do? I could put 84 divided by 15, or I could put 92 divided by 15, right? So what do you think we're going to do here? We're going to go, what? 5x cubed divided by what? Just this x. Okay, forget the minus 3 for right now. We're not going to always forget about it, but just divide it by the x. So when I say, how many times does x divide into 5x cubed? This is what you're doing. This is kind of like off to the side, all right? You might be able to do it in your head. Some of you guys could be able to do this just in your head. But let's figure out what this is. What is 5x cubed divided by x? Well, one of these x's does what? Cancels out with one of these. What are we left with? 5x squared. No, we got a long ways to go. Okay, but that's how many times x divides into 5x cubed. Just like, I'll keep referring back to this. Remember, I said this is our model problem. Just like I said, how many times does 15 go into 84? It goes 5 times, right? Now, what did we do with that 5? I stuck it where? I put it at the top. That's exactly right, okay? So I said, how many times does 15 go into 84? 5 times. Where does it go? It goes on the top. Over here, it's the same thing. How many times does x go into 5x cubed? 5x squared times. Where does it go? On the top. Just like that regular division problem. Okay, so I go 5x squared. Say it again. I can't hear you. I got bad hearing. Say it again. No? Okay. Do you see how it parallels this right here? How many times does 15 go into 84? 5 times. Where do I put the 5? Boom, right up top. We good with that part? Then you come down here. It's the same idea. How many times does x divide into 5x cubed? Well, 5x squared times. Where do we put that? Put it up top. Now, what did we do with that 5 after we put it on top? What did I do with that 5? I did what? I did something with that and the 15. What did I do with those? I multiplied them together. So I said 5 times 15 is what? 75. And then what did I do with that 75? I subtracted. You follow me on that one? Okay, it's the same exact thing over here. It's a little different because you got x's in there, all right, and you got squared stuff. But it's basically the same idea. So what do you think we're going to do to this right here? We're going to take this and multiply it by, well, this time we're going to take the whole entire thing, okay? So we're going to take that 5x squared, multiply it by this, and then do what to it? Subtract. So the arithmetic, I think, is kind of easy because I don't have to know like 15 times what is 84 or anything like that, okay? I think these are a little bit easier as far as arithmetic. But let's do it. How do I multiply 5x squared times x minus 3? I'm going to do this off to the side. 5x squared times what? X minus 3. You may, once you get good at these, you may look at this and just be able to do this in your head. But if you can't, I would do it off to the side. And that's why this little squiggly thing is here. Okay, it's just off to the side. Now, you know how to multiply this stuff together, don't you? Yeah, we did this. We had a whole lesson on this, didn't we? It's just distributive property. So what is this if I multiply them together? 5x cubed minus 5x squared times 3, which is 15x squared. Right? That arithmetic isn't difficult, is it? It's just distribute. See, we've done that before, haven't we? So it's not new. Really, nothing so far has been new. It's just putting all that stuff that we learned before together to make a new problem. Now, I multiplied those together. What did I do with it? Like on this one. After I multiplied 5 and 15, what did I do with them? Subtracted it from this stuff up here, didn't I? So what do you think I'm going to do here? That's right. I'm going to subtract it from here. Now watch, though, very carefully. You're going to put a minus, but then I'm going to put a parentheses because I got two different terms here. It's very important when if I'm going to subtract, I need to put a parentheses. And what is it going to be? It's going to be 5x cubed, what? Minus 15x squared. Close the parentheses. And now I'm going to do the subtraction. So where am I here? I'm right here, 84 minus 75. Everybody see that? That's where I am right here, okay? So now I subtract. That's kind of like my 84 minus 75, but now I subtract these. Let's see if we can subtract them in our head. 5x cubed minus 5x cubed, what's that? It's 0, so I don't have to worry about that, all right? What about, see how let's do this in a different color. Go yellow. So right there, see, I subtract those from each other, and now what else am I going to subtract? I'm going to subtract these from each other. They're just on top of each other this time. Instead of left and right, one's just on top, one's on the bottom. So they're the same term, aren't they? They're both x squareds. So really, what am I doing? I'm just going negative 3 minus, see that minus out in front? It's negative 3 minus negative 15. What is negative 3 minus negative 15? No? What happens with this minus and minus? Add a line, change sign, or add the opposite, right? Now what is it? That's 12. So what's going to be down here? 12x squared. Very good. So negative 3x squared minus a negative, which is plus, negative 3x squared plus 15x squared is what? 12x squared. Where am I with that other problem? I'm right here with that 9. See that? So I just subtracted 75 from 84 and I got a 9. Right here, I
would you please send a student down from your classroom to pick up some slips? They need to know how many students are in your class. Thank you.
Okay, yeah, thank you. So let's take a look. Now, I know this might be going a little fast for you, but you can always watch it on YouTube, slow it down, write down the steps, try to think a little bit, all right? So that's a 12x squared. What did we do with this problem after I got that 9? What's the next thing that we did? Drop down the next one. So what do you think we're going to do here? We're going to drop down the next one, okay? So let's do this in yellow again. So what I'm going to do is take that and I'm going to drop it down. Oops, I thought it was in yellow. That's okay. It doesn't have to be in yellow. So if I drop that down, what is it? It's a plus. That's very important that you put the plus there. That was a plus. It's kind of covered up by that yellow, but that's a plus 2x. Okay? Now, we're just going to do it again. What did we do here? We brought down that 92, and then we just went through the same routine again, didn't we? We said, how many times does 15 go into 92? Right? We did that division. We said 6 times, so we put the 6 up here. That's what we're going to do again. So let's do it. How many times, let's just do the x, forget the 3 right now. How many times does x divide evenly into 12x squared? You might be able to do that in your head. 12x times, that's right. I'm going to show you though. There's your 12x squared. How many times does x divide into 12x squared? So that x cancels with one of those x's. Look what we have. It's just 12x. Where do we put that 12x? Up, no, not underneath. Up at the top, okay? Because remember this one? We said, how many times does 15 go into 92? 6 times. Where did we put the 6? We put it up top. Right? Do you see how it mirrors that problem, that long division problem? Yeah. So, again, how many times does x go into 12x squared? 12x times. And it's a positive, so what do we put here? A plus 12x. I mean, it's a little bit of a long problem, but really, has it been difficult as far as the arithmetic? No, it hasn't, right? We know how to divide by x, that's easy. I know how to distribute, that's easy. I know how to add these two numbers right here, negative 3 plus 15, that's easy. So there's really nothing I need a calculator for at all on this, is there? Okay? Now, what did I do? After I put it up here, let's go back to this one again. I'm going to keep going back. After I put that 6 up here, what did I do with that 6? I went 6 times 15. You with me? I went 6 times 15. And then I multiplied them together, and then I subtracted. It's exactly what we're going to do right here. Tell you what, just so I have some room, I'm just going to get rid of this stuff just to give me some more room. So what do I do with that 12x? I take that 12x, multiply it by that thing that's on the outside, which is x minus 3. Let's distribute. What's that going to give you? 12x squared minus what? 36, right? X. 12 times 3. And what do I do with that? I subtract it. Make sure you put a parentheses here. It's super important that you put a parentheses. So I'm subtracting 12x squared minus 36x. It is kind of long, all right? But you're going to have to get used to it. The higher up you go in math, oh, you're lost? Well, that's what YouTube's for. You can go back, right, and watch it. So let's do this. Let's subtract. 12x squared minus 12x squared, what happens to that? It's 0. So really all we're doing is this. 2x minus a negative. What's minus a negative? It's plus. So what's 2 plus 36x? 38x, right? It's 2 minus negative 36, right? Add a line, change the sign, or add the opposite. That's 38. And it's got an x, so we stick the x there. We're getting there. That's right. It's all for one problem. That's right. I don't give you near as many problems for the homework as I would normally, okay? So don't worry. But this is my explanation, though. All right? I'm sitting there and explaining every little step. I'm going back up to that other problem, showing you how they relate. If I was to do this, I could do this much, much, faster than what I'm doing right now, okay? This is the first one. The next one will go a little bit faster, all right? So I bring this down right here. What? Plus 1. We're almost done. So now I go through the same routine. We've done it twice already. I got to do it for a third time. How many times does x divide into what? 38x. I only take the first ones, okay? So what is 38x divided by x? It's what? It's just 38, because that x and that x cancels. I'm just left with a 38. So where do I put that 38? Up at the top. See? The more you do these, the more you start getting in the flow, getting in the rhythm. Now, what do I do with that 38? Well, it's on top already. So what do I do with it once it's on top? I take it and multiply it by x minus 3. I don't know. Somebody figure out what 38 times 3 is. Do that, because I don't know what that is in my head. I should be able to figure it out, but so x minus 114. Okay. So this is going to be what? 38x minus 114. Oops, there goes my dumb pen. There we go. What in the world do I do with that 38x minus 114? I subtract it. That's right. Since I multiplied these together, then I subtract it from this. 38x minus 114. We're almost done. We're really super close. 38x minus 38x is 0. Positive 1 minus negative. Again, it's another minus negative. What's minus negative? It's plus. So what do we get? 115. Now, does x divide into 115? No, because there's no x's in there. So guess what 115 is? That's my remainder. Okay? But we don't write r. What do we write? It's plus. See, this is a positive 115. So we put plus. It's not over x squared. It's over x minus 3. And that ugly looking thing right there is our answer. I know I took a long time explaining it, but the first time, it's going to take a long time to explain it. All right. It's on YouTube. I'm not going to go through that anymore. Let's do one more example. This is the example they give in the book. I made this one up myself. It actually worked out pretty nice. The 115 was a little bigger than what I would have wanted, but that's okay. Let's do another one. I'm going to go a little bit faster on this one. I'm not going to go super fast, just a little bit. It's on YouTube, so you can always go back, pause it, write it down, all that good stuff. Okay, here we go. So we are dividing. I think this is what I said we were going to divide on Friday. Am I right on that? Did anybody write that down on Friday?
Is this what we was going to do Friday?
I said this is what we're going to learn today, right? On Friday? Yeah. But the x squared, it really doesn't make it any more difficult, but I just thought I'd start with an x first, just to make it just a tad easier. So we got to set this thing up as a long division problem. So what goes on the outside here? Very good. X squared plus 1. What goes inside of here? All the other stuff, right? So it's going to be 3x cubed plus 4x squared plus x plus 7. Now you have a basic idea. Look, I wouldn't expect you to know exactly how to do problems like this after one explanation, all right? It takes a while. It takes a while to practice them, to go back, look at your notes again, try to figure out what we're doing. But you have a basic idea now on what we're supposed to be doing. So what I'm going to do is this. I'm going to look at the x squared. Don't look at the plus 1 part of it at first. Just look at the x squared and say, how many times does x squared divide evenly, or let's just say divide into 3x cubed? Well, again, off to the side, if you want to come off to the side here, you could go 3x cubed divided by what? Just x squared. Let's find out how many times that divides into this. Well, I got 2x's down here, cancels out with what? 2x's here. How many am I left with on top? Just one of them. So how many times is x squared divided into 3x cubed? 3x times. Where do I put that? Up top. That's right. So that math wasn't hard, was it? It was 3 minus 2, basically. That was all the math. Now, what are we going to do with that 3x? I'm going to multiply it by x squared plus 1, all right? And then I'm going to subtract it. Okay? It's just distributive property. If you want, you can do it off to the side. After you get used to this, you may not have to come off to the side to do this, okay? I could just look at this and I'm like, okay, I'm taking 3x and I'm multiplying it by both of these things, right? Isn't that what distributive property is? So 3x times x, well, let's do this, x squared plus 1. What's 3x times x squared? It's 3x cubed. That's right, because remember you add the exponents. Plus what? 3x times 1, which is just 3x. That's what we're going to subtract. So we put 3x cubed plus 3x. Okay? Wait a minute. Hold up. Wait a minute. Wait. Why is it doing this? Let me look at my notes. Okay, that's fine. Sometimes it'll do this when you have an x squared on the end. I forgot about that. So watch what I'm going to do. And Ray said it. You didn't hear it, but I heard it. He said, you can't subtract these. Why can't you subtract these? There's no squared here. So where do you think I'm going to put that? Yeah, I'm going to put it under, right there, under the x, so that I can add them together. So that was a little tricky, wasn't it? Absolutely. Sure. So what's going to go here, though? 0, right. It's not an x, because x is something. What if I did this? What if I just said 0x squared? Couldn't I do that? That was a little weird. I get it. I understand it. I understand the rumbling that we had. All right. But if you look at this, I mean, I had to even look at it. It's literally been 10 years since I've done a problem like this. Okay, so it's been a while. Oh, you absolutely need it. It doesn't matter if we need it for life. This is just learning how to think through a situation. Will you ever have to think the rest of your life? I think so. All right, so this will help you practice thinking. Whether or not you use this math the rest of your life, that's insignificant. Will you have to learn to think? Sure you will. Okay, so that's what we're trying to do. All right, so let's see what happens. 3x cubed minus 3x cubed, that's 0. 4x squared minus 0x squared, what's that? That's 4x squared. Yeah, that's easy. Just subtract a 0 from it, right? Yeah, that's easy. What about this one? This is an x or a 1x. So it's 1x. It's not plus 3x. What is it? It's minus, right? Because of that minus out there. So it's 1x minus 3x. What's 1x minus 3x? It's not 2x. What is it? It's negative 2x, minus 2x. That's very important. Okay? So what am I going to put here? Minus 2x. Right? All right. Again, go back and look at it. All right? And then just do it from scratch and just write down every step. Pause it. Think about what you were doing in that step before you go on to do the next step. Now, we got to ask ourselves, and we're almost done this actually, watch. How many times does x squared divide evenly into 4x squared? Well, if you need to write it down, let's put it over here off to the side. So 4x squared divided by what? X squared, right? Because it's not just an x out here anymore, it's an x squared. So what's 4x squared divided by x squared? It's just plain old 4. See those x squareds cancel out? And I got a 4. What do I do with that 4? I put it up top. That's right. In fact, I'm going to actually, yeah, we can put it. It doesn't matter where we put it. Put it right next to it, okay? So I put it's positive, right? So I put a plus 4 up here. Now, what do I do with that 4? Multiply it by this stuff and then subtract. We're pretty close to done, okay? So I take this, all right, All right, I take this 4 and I multiply it by this stuff right here. Can we do that without writing it off to the side? 4 times x squared, which is 4x squared, and then 4 times 1. Oh, what am I going to do here? I'm going to have to move it again, aren't I? Because I can't subtract from a 2x. That's not that bad. You guys are freaking out over this, but it's really not that bad because you're looking at it and you're like, well, wait a minute. I can't. This is going to be a plus 4. I can't take that away from a 2x, so what do? I just put it over here, so it's underneath that. So now I can add those together. Actually, subtract because it's 7 minus. What do I put in here? Put a plus 0x so that I can add some x's together. You did this when you did long division problems. Remember you put like zeros in there for place value, hold the place value and all that kind of stuff. It's kind of the same thing. All right? So let's see what we got. Actually, we could drop this down, couldn't we? Put that right there. You with me? So let's see what we got. 4x squared minus 4x squared is 0. Negative 2x minus 0 is negative 2x. Now be careful with this one. It's not 7 plus 4. What is it? It's 7 minus 4. 7 minus 4 is what? Positive 3. Now look. How many times... let's do this. Let's move this up just a little bit. So we say, how many times does x squared divide into negative 2x? Well, we're not going to do this because it's not going to come out to a whole number. Do you see that? Because this x will cancel with this. We're not going to get a 2 over x. So what is this? This is our remainder. Okay? So now what we're going to do is just write the remainder. So, yeah, I'm going to put a plus here. So what's our remainder? Negative 2x plus 3 over what? Whatever we're dividing by. What are we dividing by? Yeah, the remainder shouldn't be a big deal, okay? Know that you can't divide anymore, all right, and get a whole number out of it. So we're just going to say that's our remainder. We just stick the remainder over what we're dividing by. Is that really any more difficult? No. All right, and that right there is your answer. Aren't you glad we did the first one first before we did this one? Because the moving the numbers over was a little bit weird. Okay. There you go. I warned you, didn't I, at the beginning? I said this is going to be a little bit challenging. You're going to get frustrated. Okay, I get it. I've been there. Remember I told you the story when I was in college, right? The teacher was looking at us like, why in the world don't you know this? You should have known this in high school. Well, none of us, even the real smart kids, and I wasn't one of them, okay? Even the real smart kids had not seen this in high school. But now, guess what? If you're in a calculus class and the professor looks at you guys and say, don't you remember long division with polynomials? You're going to say, what? Yeah, I remember doing that. You might say, well, I don't remember now how to do it, but at least I remembered learning it, right? All right, and there it is. So there are situations. Look, I'm serious. Somebody asked me a question, when are we going to use this in real life? I would probably venture to say you'll never use this. Okay, the only time I've ever used this is when I'm teaching it to students, okay? But listen, it doesn't mean, listen now, Will, you're not even looking up. At least look up when I call your name 3 times. Abu? Thank you. See, he looked up the first time. So, just because you're never going to use it in your job or anything like that does not mean that it's not important to learn. I think that what we're doing in here, whether or not you actually use this and translate it to a job, which is probably going to be very rare. But the thing what it's doing, it's teaching you how to see something that you didn't know how to do before, learn how to do it, and then go ahead and be able to accomplish it. There's going to be a ton of situations the rest of your life. You're going to go to jobs. You're not going to know how to do a job. Somebody's going to come and say, okay, this is how you do it. You didn't know how to do it before. They're going to show you how to do it. You're expected to learn from them, and then you're expected to be able to do it. You're going to have that situation over and over and over again the rest of your life. So this is a great example. Whether or not you use this division of polynomials in a real job, that doesn't make any difference. We're learning how to learn. Okay, that's what's important right here. Okay, you got to get out of your head, well, I'm never going to use this the rest of my life, so it's not even worth learning. I had a kid, I don't know if I told you this, I tell most of my classes, but in my other school, I had a girl that refused to do the homework. I'm like, why do you refuse to do the homework? She says, well, I showed it to my mom. My mom said she's never used this stuff in her life, and then I'll never use it, so I don't have to do the homework. I mean, what a terrible role model, okay? That's awful. I couldn't believe it. Now, I wasn't going to say anything bad about this girl's mom, obviously, but I'll tell you, I think that's ridiculous, okay? Because it's not about just the math. That's not what it's about. It's not, okay? For some people, it is. Do some people use this stuff in that calculus problem? Do they have to do that? Yeah, they did have to do that. Can you use calculus in the real world? Absolutely. People do it all the time. Engineers, architects, people like that. People that work with electricity and things like that. Yeah, they use it all the time. Will you do that? Maybe not, but maybe you will. You never know. But the fact that you learn it just for the fact of learning how to learn, I think, is important. And this is not just a bogus reason why I tell kids to learn math, okay? I truly believe it. I absolutely 100% believe that it's important to learn stuff in here because you're going to have to learn stuff from other people the rest of your life. Okay, what did I give you? I gave you the lesson plan thing, but I'll write it down anyway. What is it? It's R.4C, right? So it's R.4C, and it's page 49, and you are doing 89 to 103. It looks like a lot, but you're only doing half of those, right? You're only doing the odds. All right. Give it a good shot. Give it a good shot. I'm going to give you more problems to practice tomorrow, and tomorrow we'll go over some of these problems. Okay, don't just say, well, Mr. Hammer's going to do it in class anyway. Don't do that. Give these a good shot, all right? Give it your best effort, and then you'll be better for it. All right, enough of that.